Okay, thank you very much, Mark, and I want to thank all of you for your patience and staying with us so late. Today I'm going to talk about spatial domain multiplexing. We believe it's an optical fiber solution to bandwidth multiplication. We have a very strong team composed of academia, industry, and tech transfer. And I am Syed Murshid, and I'll talk about the rest of my team as we proceed. So what is spatial domain multiplexing? It is a telecom solution that can multiply the bandwidth of systems. The vision behind it is that when a photon enters a fiber, from the perspective of the photon, it is effectively in the Grand Canyon. So why can't we use the rest of the space? If we can do that, then we should be able to go and do the spatial reuse of optical frequencies. It has been a dream in the optical community ever since optical fiber came on, but because the size of the fiber is about the size of human hair, it was very difficult to do so. Signal to noise ratio was the basic problem. So we have come up with a technique that allows us to reuse the spatial frequencies, and we are able to develop systems that can be easily retrofit into older fibers which are running at capacity. Initially, we want to go and market fibers which are already running at capacity, and then gradually we want to transition into areas such as single mode fibers or long haul communications. The capacity can easily be doubled. We have already done it in the lab for over a kilometer length. That basically tells that it can be applied to most LAN applications as we speak. Okay, and the proof of principle was demonstrated in 2005. The beta prototype is already in progress, and we already have a patent on this technology. Why SDM? Why now? Before I go any further, let me tell you that I'm guilty of copying this image from web. It is not my own. Okay. What happens that everybody needs more data, and this is not something that can be disputed. Okay, even at my home when I was using 24K, now 2.4 megabits is slower. I want a 15 megabits. They want $20 more. I still need to think, do I want it or not? So more data is required. At businesses, at secure locations, and not only that, even at homes. Everybody now wants to go and download video files. So more data is required. That's the bottom line, and I think it cannot be disputed. Bandwidth, in addition to my home, it is an issue at places like Pentagon, where you have the world's greatest fiber, world's greatest network, ending right at the doors. Inside the building, we have very, very old fibers. All the ducts, all the trenches are full, okay? And although most of the generals want the video directly on their desks, unfortunately, they cannot get it. Kennedy Space Center is another thing very close to us. I'm privy to some information. They have about 30,000 kilometers of multi-mode fibers, OC3 fibers going into the buildings. Between Launchpad 39B and vehicle assembly buildings, they want more data, they want to have videos at most places. Technology allows you to do it very inexpensively now, but their bandwidth would not allow them to do that. Campuses, hospitals, battleships, anywhere you go, that is a problem. You can lay down new fibers, but that is an intrusive technique. You have to tear down walls, you have to tear down offices and desks to do that. So the best solution would be that you can have the fastest network over here, but somewhere at the switch boxes, simply plug in one or two small modules, one or two small boxes, and you are good to go. So if we can do retrofit there, or we can retrofit existing installations, and those installations do not involve any rocket science, a technician can do it in a few minutes, then I think we have something that can be practical and finally go to the real world. So what is spatial multiplexing? As I told you, it's the bandwidth multiplier. It is about an order of magnitude cheaper than what the competition can offer, and I'll tell you why. The advantages are no moving parts, repeatable, you can easily retrofit. And why you can easily retrofit? All we do, this is your existing network right in here, this portion. We simply add an spatial multiplexer and a spatial demultiplexer. The thing I ran around, that is the spatial demux. We have already designed it. Okay, so, and in that chip, we have actually 6 of those spatial demuxes. We are still running through the beta types, trying to configure or figure out which is the best solution for us. So that is the spatial demultiplexer. On the other end, here is our spatial multiplexer. Combine these two and you get output over here. That is center spot and a second spot around it. And if you want, you can have up to 6 different channels that we have done it and published it. One of them, I think, last August in California in one of the conferences. We have done up to 6 channels on different multimode fibers. On standard communication fiber, which is very commonly used in LAN applications, we have already done it for 2 channels. Okay, in a system using like this one. So it is inexpensive, non-intrusive, comes at the 2 ends. Okay, and we have 2 simple add-ons. Okay, again, the multiplexer and the demultiplexer, we call it the beam combining module or the beam separating module. Okay, fiber optic cable usage. And I'm not talking about the optical fiber or optical communication market. I'm basically competing about optical fiber usage itself. That instead of somebody laying down a new fiber, use my technique, in a few minutes you're ready to go, your bandwidth is doubled or has gone 4 or 6 times whatever it was. Okay, so optical cable usage market is growing at about 20%, just like optical communications market. Annual sales of optical cables alone is 1.8 billion. That was in 2005. And for optical fibers, I think the data is kind of at 2 extremes, from 10 billion to 30 billion dollars per year. But optical cable usage is at about 1.8 billion. That was in 2005. In 2008, we estimate that to be around 2.8 or roughly $3 billion, and almost half of that to be in North America alone. So we are going to look for a very, very small share of this whole market, that about $4 million in the first year and about $64 million in about 5 years' time. But we don't want to stop at that only. At about 3 years' time, instead of going through OC3 fiber, we want to go and start addressing OC192s and OC48s as well. Okay, we have already done a lot of modeling, mathematical modeling and simulations and tests that tell us that it can be done into single mode fibers as well. And just recently I was glad to be able to catch the eyes of Dr. John Caulfield, who is probably one of the leading most experts and one of the most renowned experts in this field. Okay, so this is the game plan, but initially I'm pretty sure that we can certainly meet this goal, not necessarily in terms of numbers. Their marketing is not my best suit, but from the point of view of technology, we can go there in about a year's time and start. If the market works out fine, we can sell these devices. What is the competition? If somebody doesn't want to do anything, there is very little I can do. So status quo is one of the biggest competition we have. And another thing that I have no clue what may happen in future, that is a new technological breakthrough. I can only make a fool of myself by predicting the future. But whatever is available, new cable installers, wireless techniques, and free space optical networks or optical links, these are the 3 competitions we have. And if we look at it, okay, my SDM is right at the bottom. It is, I think, better in all areas except in terms of bandwidth. If we want to lay down a new cable at a single mode fiber, they will offer you better solutions. However, our technique can still go and double whatever they have using the technique I just showed. So bring on whatever you have. We believe we can simply double it, even though it may be a single mode fiber. We haven't done it physically on single mode fibers. We have done the modelings, and those modelings do predict that yes, it is doable. But on a multi-mode fiber and the OC3 links, like places like Pentagon and other, we are good to go. Okay, our commercialization team, if you see, we have people from academia, industry, and tech transfer. I'll be the PI in this on this endeavor. I teach courses in photonics, fiber optics. I have multiple patents on this specific field alone. I have other patents in other areas, but in this field alone, I have multiple patents and patent disclosures. I think just this year, I have about 10 publications on this specific subject alone. Okay, and some people in Florida liked me, I guess. Okay. Dr. Musche, he was the ex-department head of, he is currently the department of, head of engineering systems. Previously, he was the associate dean of the School of Business. He basically teaches how to deliver projects that meet specifications and they are delivered on time and on budget. So that is his strong suit, and on any project, that is one of the biggest things that engineers need to learn. And being an engineer, I guess we are guilty of always being late and mostly being over budget. So Mus basically stresses on that. We have great graduate and undergraduate students who will be helping us with that. But on top of that, we have been able to get, and in fact, we were lucky, and thanks to Bob, who is our tech transfer director, we were able to get some excellent help from industry. Dr. Paul Sukowski, he was the CEO of Optium Corporation before Optium merged with Finisar. And when Optium and Finisar merged together, people said that now JDSU has its competition. Dr. Richard Fox, he is the partner at Astralis Group, and he, for the last 20 years, he has been building, financing, and growing technology-based companies. So they have agreed to help us, okay, and Dr. Fox, more than everything, a very pleasing personality and really fun to work with. Then in tech transfer, I have Mr. Robert Merrill, my friend, so grateful to all his help, always there to listen to us and help us whatever way he can. He would be helping us with the IP licensing and contract negotiations. And Dr. Michael Martin is also on board. He used to be the vice president of IP transfers and things like that in Virginia Tech at the time when Murphy and Gunther, those guys were developing their Fabry-Perot fibers based on optical, Fabry-Perot interferometers based on optical fibers. So he's also under the team. He's helping us market and trying to develop licenses for this technology. What are the risks and developments, or what we want to achieve out of it? Okay, the design and development of a test bed, that is the first thing we want to do. Indeed, 10K doesn't go very far, or 20K doesn't go very far, but there is a very good place called eBay. If you know that and you are willing to take some chances, 20K can be leveraged to more than 200 to 300K. I just bought a special type of fiber optic splicer. I was looking for a specific type that was around $37,000 in the market, and finally I was able to get it for $1,500. Okay, thanks to eBay. That is for any of things like what we do. That is our that saves us from many hassles. It takes some time, but it's worth it. Other technology risks, as I told you, that there could be a future technology, and my technology may not be needed. I would not say that it is not possible. I can only make a fool of myself by predicting the future. Okay, some other challenges over here would be early business developments, and most important of all, successful field trials. If we are able to do the field trials, we have done it in the lab, but it takes a lot to go from the lab to the real world. Okay, the very moment we can do that, we are good to go. I think it is very good for Florida Institute of Technology. As you see, we have a very diverse research area. The same optics, Kunal is doing something entirely different. I am doing something entirely different. And we have a big number of faculty who are working in different areas over here. So we have an excellent pool of faculty and students, and we can leverage that. Our existing infrastructure in my own department, electrical and computer engineering, we can leverage that. We have a photonics program. It fits directly into that. My optronics laboratory, it fits directly. It is coming out of that. And then we have light wave lab and Kunal's, again, laser-based meteorological lab, sensing lab, laser optics and sensing lab. So this technology basically feeds into all of those. We have a Florida Tech matching of $1 for every dollar that we would be getting. On top of that, I'm not charging for my time. I'm not charging for Bob's time. Dr. Sheikh's time or the times of all other people. Bob is taking care of that. I don't have to pay them out of this grant. So I think we can leverage whatever we have in a very efficient manner, and with the help of eBay, we can take it to a few $100,000, I can guarantee you. Okay? It may be a little slow, however. This also complements the existing patents, patent applications, and disclosures that we have. Okay, the thing I just passed around, that is another patent disclosure that we have on that. Okay, and it also complements the interest of the faculty and the students, and some of the tools that we will buy. Okay, some of the equipment that we will buy will feed on into not only our research for this project, they will also be available to other faculty. So it has a more broader application. The activities that we plan, first and foremost, optimize the design. Okay, I am sitting on planned activities, which is very good to go. Okay, thank you. We want to optimize the design. If you look at our written proposal over there, we basically say that we will be developing a CAD model. In here, I'm not talking about the CAD model, because between August and now, we have already developed the CAD model. It's almost 80% done. Need to refine it, so we changed our this, and I'll give you a refined proposal if it is acceptable to you. Change the CAD model into these steps, okay, because that is already done and don't want to charge you for something which is already done. So we will optimize the design, finalize the prototype, and let me be upfront, I'm not a business person. I like to live in my dark room, burn the nights oil. So we need help with business case analysis through professionals. And that is where Dr. Richard Fox and Dr. Paul Sukowski come into the picture, and they have agreed very graciously to help us with that. And especially with Paul Sukowski, he has taken Optium from 6-man team to a few thousand people team. What are the further steps? If we want to go to the market, we need to nurture partnerships with basically telco equipment manufacturers. Okay, need to raise angel investment for field deployments, whatever I have been able to show you. Indeed, that chip takes about $200,000 to build, but thanks to a program called Moses, we were able to do it for maybe $500, and that was for bonding only or packaging. Okay, so need to raise angel investments and field deployable prototypes. As soon as we have that, we can actually go and real world tests. Okay, need to raise venture capitals for product launch. Okay, and finally, we need to find the channel to the market that is sell the MUX or DMUX boxes, the multiplexers and the demultiplexer boxes to the telecom equipment vendors and manufacturers. And the most common ones are Cisco, Nortel, JDSQ, Finisar, etc. We don't want to go to every door that this is what we have made and please buy it. If we can get to some of those, then this would be a lot easier marketplace for us. Okay, and I believe I'm ready for Q&A. The sound is off.
Do you even have to?
Okay. What's the theoretical limitation? Is it 4 channels? Or
No,
you can go more?
theoretically, we can go up to 10 channels on a multi-mode fiber. Okay, I think if you want to be very safe, up to 5 channels we can safely do. Okay, and that is what I believe we can do. On single mode fibers, we can certainly do at least 2. Okay, and the very moment we do it, this complements time division multiplexing.
Or just so we can catch you on you. No worries, no worries.
This complements time division multiplexing as well as WDM. So the beauty is, the very day I prove it on single mode, bring on whatever you have, we can simply double it. And the day I do that, then we are talking about tens of billions of dollars and not a few tens of millions of dollars. So that is the goal where I want to go. We have done all the modeling, and there's nothing that should stop us from getting there. So I hope that answers your question.
How does freeing up the land within the local building domains, how does that relate to the growing usage of Wi-Fi in local domains?
Wi-Fi will always be limited by the frequency that you are operating. If you are operating at 2.4 gigs, the theoretical maximum is 4.8 gigs. That is one limit. Secondly, when the buildings and other things start coming in there, there is a problem with the range and the bandwidth, because I don't want an antenna running on my head. So Wi-Fi is a competition. In my home, we do use it, but you end up not with 48 megabytes, not with 24 megabytes. If I check my computer directly, that is giving me close to 7 megabytes. When I look at the same thing through my Wi-Fi network, I'm getting only 2 megabits per second. If you're trying to get a video, Wi-Fi may not be the best thing, especially if you have some distance over there. So yes, it is a solution, but is that an optimum solution? I'm afraid not.
So is this a complementary replacement for products that are in JDSC's?
It is a complement that whatever they are doing, instead of sending one channel at a time, why not we send 2 channels? And it's kind of hard to believe that it can be doable, okay? But here is the real world data. One of the problems that happened, that Gloge, I don't know, does it mean anything to this audience or not? He did some tremendous work in the 70s, that is still the Bible of optical fibers. But he said the output E field is an exponential function. You have to go beyond Gloge to actually address that. Look at the angular momentum of photons. Once you look at the angular momentum of photons, take the approach presented by Nye and Berry, complement it with angular momentum, this is what you get. And I can actually tell you that these days I'm chasing shadows. If I take a piece of wire over here in front of this, instead of the shadow being a straight line, I will get a crooked shadow because of the angular momentum of photons. And that is what's happening in here.
Definitely when you answer too, if you can try to use the microphone as much as possible so we can...
I'm sorry.
No worries, no, it's fine. And also live questions if you can.
Yes, sir.
So are there components of this that really, that still, I mean, I'm a little unclear as to how certain you, I mean, how close to market this actually is. So what are the issues that you still need to address before this could actually go to market?
Two things. Initially, when we were doing our
That's okay.
When I was doing my demultiplexers, initially we were using an array of lenses. And lenses and others are great, but they are not reliable. So that was one of the biggest challenges, and we have finally resolved it using those chips. Now all you need to do, plug in the fiber and you are good to go. So that is one thing. That was one of the biggest challenges we had. We have taken care of that. Second, we are able to work with this design. But I would like to have this one a MEM-based design. A MEM, a microelectromechanical system-based design. So if it is a MEMS-based design, then that would be really something that you can take into market. I can take this one in, okay, I can make some kind of a kludge-together system like these over here. These are different versions over here, but more than that, what is actually needed, just like we have the detector here instead of this lens array, the detector over here, and this is what you folks are seeing finally. Okay, we want to do it at the MEM. But to prove the concept, we have used this system, we have used the lens array, and over a kilometer, we got that output that I showed you. That was the output after 1 kilometer. Most LANs are about 1 kilometer or less. So yes, LAN, we are ready to go. We can always refine it, make it better. I am not very happy with this design. Okay, after I am done with this thing, okay, my students would have the next task of working on a MEM-based design. So we can go to the market now, but that wouldn't be the optimum design. It may be a generation or 2 generations before the optimum design. Yes, sir.
How much money have you put into this project then?
Don't ask me. Bob will feel bad.
I mean, roughly, because you demoed it in 2005 and you filed a provisional in 2006. And
if I take my time and the time of the students and the other people helping me, it may run in a couple of $100,000. But real dollars, if you want to ask, it's about under 10K. So under 10,000 is what we have actually spent. Unfortunately, we did not get any funding from NSF on this thing so far. Okay, So whatever other sources of fundings we had, internal funding and this and that, which is very limited. So I haven't spent even 10K on that, and that's why we have to go to a place called eBay.
Okay, yeah, and I'm just going to ask you a question that I've been thinking about
Yes, sir.
asking before. But what's the use of proceeds on the 10K? And what are you going to give me if Mark gives you 10K at this stage in this project? Let's call it that, because I understand that there's a lot to be done. What are you planning on trying to do and deliver for that 10K? That's a little bit more definite than that, because that's quite the list there. I mean,
basically, this is the thing I want to do at 10K. Design and develop the test bed. Now, very frankly, even if I don't get it, I'll continue working on this. I've been working on this for the last 5 years. I have been chasing shadows, and I love chasing those shadows.
Right.
The first time
you're
I
gonna
saw...
buy some hardware. You're going to buy some hardware on eBay, and you're going to continue to have students.
Yes, what I want to
That's
do is
probably
to have 2 identical bit error rate testers at eBay working at 166 megahertz, where I have electrical inputs. Once I have it, I will connect it to my detector, and I'm ready to go. So yes, I have all optical bit error rate testers, but I need electrical bit error rate testers to go and test it at 166 megabits, get the eye diagrams, and then it has already been either proved or disproved in the real world scenario. We have transferred videos, transferred files using our techniques, but you need to have the exact bit error rate tester. And the current bit error rate tester we have, those are way more hi-fi, but they not directly integrate with that. The reason was it did not have those photo detectors. Now we can integrate the photo detector, and we are good to go.